Okay, so we did degrees to radians. The other way around works as well. You can set up a proportion, put the numbers under degrees if they are degrees, put the numbers or unknowns under radians if they are radians, right? And then you cross multiply and solve for the unknown value that you're looking for. So this is the same either way, from degrees to radians, radians to degrees. I'm gonna do one from radians to degrees. Okay, so let's do, let's say, problem A, we're gonna convert from radians to degrees. Notice that the angles are given as 7 pi over 4 in part A, and nothing is described what kind of in units, so you know it's automatically becomes radian, right? So we want to convert that. So I'm gonna do the traditional method, which is the setting up the proportion, but I'm gonna show something about using the conversion factor as a fraction. Okay, so again, I have degrees, I have radians. By the way, you can put this in any order you want. So we know that 180 degrees equivalent to pi radians. Now I have 7 pi over 4, which is radians. So I'm going to list that under radians. And I want to know what is that in degrees. So the fractions, the divisions of these values are equivalent. So we're going to cross multiply and solve for x. So pi x should be equals to 180. Notice that there is no other degree to cancel, right? So I'm keeping the degree symbol there, times 7 pi over 4. Okay, so it doesn't say how we should present the answer. So I'm assuming that I will keep this as a fraction as long as in the lowest form. I still need to solve this for x, so we need to divide both sides of this by pi. So I get x isolated. One thing that you should notice on the main fraction here, I have a multiplication on the top. Notice that I can cancel 80 with 4. So 180 divided by 4 is 45. So basically on the top, I have 45 times 7 pi. And that's still divided by that pi in green on the bottom. And pi also cancels pi. So basically all I need to do is multiply 45 times 7. So 45 times 7 is, and remember this is still degrees here, 315. So 315 degrees is the same as 7 pi over 4. Also, let me now using the conversion factors. Okay, so that is slightly modified. It's equivalent. It's the same thing as if I do the setting up proportions. But I want to use the conversion factors. So using conversion factors. So one of the conversion factors is 180 degrees is equivalent to pi radian, right? So if this is true, it means the 1 is the same as 180 degrees divided by pi, because if they are the same, it's like I'm dividing the same number, the result should be 1. Or you also have that 1 is the same as pi over 180. So you could use one of these fractions to do the conversion. So all you need to do is giving an angle in a certain kind of unit, either degrees or radian. If you multiply by an appropriate fraction that is equivalent to 1, you're not changing the value, just changing how it looks. Basically, you change the units. So let me give you the example that we just saw here, which is 7 pi over 4. Right? So I did the same example I just did. The answer is going to be the same. So we have 7 pi over 4. Now this is radians. Since I want to convert from radians to degrees, it means that my fraction should have degrees on the top, because radians on the top will cancel with a radian on the bottom, and what is left over as a unit would be degrees. So I'm going to multiply by 1 here, but 1 for me is actually the fraction that you saw above. Instead of writing 1, which is equivalent. I want to multiply by one of this fraction. I want to take this fraction right here, which is the same as 1, because the degree is on the top. So radian bottom, which cancels the other radian. So if I multiply by that conversion factor, that's enough. So this multiplication already gives me the conversion I need. I just need to simplify. For example, I can simplify this. I cancel both pi's. I cancel 180 with 4. We already know this is 45 degrees. So the answer is that if I take 7 times 45, which is the 7, with the 45 here, I get the same. In less steps, of course. Okay, so let's do one more here, example number 15. Okay, we're going to convert from radians to degrees. I'm going to use the fraction this time. And we're going to round to the nearest hundredth, 2 decimal place. Doesn't matter which one you pick. Notice that we have, for example, 3.7 radians. So again, this is radians, and I want to multiply by a fraction that is equals to 1, but that fraction needs to have degrees on the top. So that means I have to multiply by the fraction 180 degrees divided by pi radians. Again, in this case, there is no cancellation needed because the answer should be an approximation. So we're good just to ask the calculator what is 3.7 times 180 degrees, and then we divide by the value of pi. So the calculator is saying that I get approximately the value. So 3.7 is approximately. I'm going to put all what I see here, and I'll show you what's the approximation. So 0.9943842. So I want 2 decimal places. So I'm looking at this, but it depends what's coming next, because 4 is less than 5, 9 stays as it is. So the approximation here is that 211.99 degrees, right? Remember, this is 2 degrees. Okay, so so basically you can do the conversion by using the factors, 180 equivalent to pi radians. You can set up proportions. I understand small steps. Usually students don't have a problem with that. You want to do the first way, just be sure you pick the right fraction.